This is our second empirical formula video. In this video we're going to be looking at how to do an empirical formula, but we're going to look at how to find the mass of the components using combustion reactions. You'll notice here that the steps are very much the same as before. We're going, except this time, instead of being given the percentage or the mass of the elements, we're going to calculate them using a combustion reaction. It can also be done from other types of reactions, and later on as you start doing these you'll also see that they'll use titration and they might use precipitation reactions in order to calculate the mass. The rest is pretty much the same. We'll create a table, find the moles, simplest ratio, and work out the empirical formula. Then we'll work out the molar mass from the data. We'll work out the ratio to find the molecular formula, and finally, if we've been given enough information, we'll be able to draw the structural formula. Okay, so this is set up like a fairly typical problem. A sample of an unknown organic compound was found to contain carbon, hydrogen and bromine. Upon complete combustion of the compound, it gave 1.76 grams of carbon dioxide and 0.719 grams of water, and the rest was a bromine product. So this first section is going to allow you to calculate the empirical formula. Now let's have a look at the second statement. A 1.5 gram sample of the compound was found to have a volume of 0.245 litres at 100 degrees Celsius and 100.3 kilopascals. So this here allows us to work out what the molecular formula is going to be. The third part of the problem usually gives information which will allow us to determine the isomers, and this information in this case is just telling us it's a saturated compound, but in other forms of information it might tell you how it reacts or how it behaves with other compounds. This allows you to work out the name and structure of the compound. So a 3.75 gram sample of an unknown compound underwent combustion, and it gave us 1.76 grams of carbon dioxide and 0.719 grams of water. So this compound is CXHYBr, undergoes combustion, and it's going to give us CO2 plus H2O plus a bromine product of some sort, which doesn't tell us. So we had a 3.75 gram sample here. It gave us 1.76 gram sample of carbon dioxide and 0.719 grams of water. So the first thing is we need to know that all of the carbon in this compound ended up as carbon dioxide, all of the hydrogen in this compound ended up as water, and the bromine was whatever was left over. So the first step we're going to do is we're going to find the number of moles of carbon dioxide, which is equal to a mass over a formula mass. In this case, the mass is 1.76 divided by 44.01, and this comes out to the number of moles of 0.03999 moles. The number of moles of carbon is going to be the same, and we can now find the mass of carbon, which will be number of moles times formula mass, which is 0.03999 times 12.01, and this will come out to 0.480 grams. Now we do the same for hydrogen. So the number of moles of water is equal to a mass over a formula mass, which is equal to 0.719 divided by 18.016. This will give us the number of moles being 0.0399 moles. From there we can find the number of moles of hydrogen, which will be, as you can see here, twice as many, which will come out to 0.0798 moles. So the mass of hydrogen will equal number of moles times formula mass, which is 0.0798 times 1.008, and that comes out to be 0.080 grams. Now the mass of bromine will equal 3.75 minus the mass of carbon, 0.48, minus the mass of hydrogen, 0.08, and it will come out to 3.19 grams. So now what we've done is we've found the masses of each component of this compound. So the next step will be to do the empirical formula. So it's now time to set up our empirical formula. So we've got our three elements, carbon, hydrogen, and bromine. We've worked out our masses. So the mass of carbon was 0.480, mass of hydrogen 0.080, and the mass of bromine 3.19. Now once again we have to find the moles. So the number of moles, remember, is equal to a mass over a formula mass. So the formula mass of carbon is 12.01, hydrogen 1.008, and bromine 79.9. Now we've actually already previously calculated our moles, so we don't really need to do it again, but you can if you want. 399 moles. This one, remember, was 0.0798 moles, and this one we need to calculate, it comes out to 0.0399 moles as well. So now remember, in order to find the simplest ratio, we divide by the smallest number, which is going to be 0.0399, and the simplest ratio is going to come out as 1 as to 2 as to 1. So our empirical formula in this case will equal CH2Br. So now that we've got the empirical formula, we're actually up to finding what the molecular formula is. Now to do this, we have to find its molar mass. So we have to use the information provided. We've been told that a 1.5 gram sample occupies 0.245 of the litre at 100 degrees Celsius and 101.3 kilopascals. Now we've got enough information there to find a mole. So we're going to do that using PV equals nRT. So the first thing is, remember, temperature must always be in Kelvin. So 100 at 273.15, and it comes out to 373.15 Kelvin. So using PV equals nRT. The pressure is 101.3 times the volume, which is 0.245 of a litre. The number of moles we don't know. The gas constant we get off the data sheet, and the temperature is 373.15. Rearranging, the number of moles of this will equal 101.3 times 0.245 divided by 8.314 times 373.15 will equal 7.999 by 10 to the negative 3 moles. Now those moles correspond to that mass. So we can go, the number of moles of this particular compound will equal a mass over a formula mass. The formula mass equals mass over moles, which will equal 1.5 divided by 7.999 by 10 to the negative 3, and that comes out to be 187.5 grams per mole. Now that we know the formula mass, we can work out the empirical formula mass. So the ratio will equal the molecular formula mass over empirical formula, which comes out to 187.5 divided by carbon is 12.01, add 2 times 1.008, add bromine, which is 79.9, and it comes out to 93.9. So this number comes out to 2. So the molecular formula will equal 2 times everything. So 2 times 1 is 2, C2. 2 times 2 is 4, H4. 2 times 1 is 2. Br2. So now we're up to working out the name and draw of any isomers. So we've been told it's a saturated compound, which means it's all single bonded. So I'm just going to have a go at trying to draw this up. So I've got carbon and carbon, they have to be single bonds. I've got 4 hydrogens and 2 bromines. So here is one particular isomer, and that isomer, remember, the bromines are the functional groups and prefix, so they are located on the lowest carbon will be carbon number 1, so it'll be 1, 1 dibromo ethane. Now there is also a second isomer possible, so I'm going to draw that as well. And this one would be called 1, 2 dibromo ethane. And there we have it. We've solved our problem. So try some yourself now. Continue on with empirical formula calculations. Number 1, question 6 onwards has empirical formulas where you use reactions to determine the mass of the constituents.